ECO2. Natural waterway restoration. Lakes, rivers, and estuaries are vital in sustaining life on Earth. Each body of water has a unique ecosystem, with a limited capacity to naturally process nutrients and organic material. Harmful algal blooms are becoming more frequent, indicating the common occurrence of a serious problem growing below the surface. Consider the water column of a lake. The very bottom is the sediment-water interface, where oxygen is steadily consumed by decomposition of settled material. When dissolved oxygen is present, the lake can naturally process external inputs, like fertilizer runoff and industrial discharges. Over time, the accumulation of nutrients and decomposing material causes oxygen depletion and a detrimental chain reaction called the internal nutrient cycle. Anoxic conditions at the sediment-water interface allow soluble nutrients to remain in the water column, fueling algae growth and decay, further depleting oxygen content and perpetuating the cycle of internal nutrients. But the cycle of internal nutrients can be stopped with a Speece Cone Oxygenation System. By providing dissolved oxygen directly to the sediment-water interface, favorable conditions return. Phosphorus, iron, and manganese are sequestered in the sediment. Ammonia is converted to less toxic nitrate, algal blooms are prevented, and water quality is restored. The equipment can be submerged on the lake bed or installed onshore. In both configurations, a side stream pump continuously circulates raw water through a cone-shaped reactor vessel, known as the Speece Cone. Piping draws intake water from above the sediment and returns the oxygenated side stream to the same depth. Oxygen gas is piped from a storage tank through a flow control panel and connected to a port near the top of the Speece Cone. Inside, it's simply physics. A highly turbulent zone is created by the inlet water velocity and the countercurrent buoyancy of the oxygen gas. The cone-shaped geometry allows a steady decrease in the downward water velocity, preventing the entrainment of undissolved gas at the discharge located on the bottom. Each system is custom designed and built to match the specific size and scope of a project and provides a near-perfect oxygen transfer efficiency of 90 to 95%. Unlike traditional aeration, which causes vertical mixing, ECO2's oxygenation approach recirculates oxygen-enriched water horizontally across the sediment-water interface, without adding gas bubbles to the water column. As the oxygenated side stream is returned at the same depth as the intake, the low temperature gradient promotes horizontal distribution across a large area of influence. Within 3 weeks, aerobic sediment conditions extend over 3 kilometers from the discharge of the Speece Cone. Over 30 years of field data have been collected, peer-reviewed and validated by leading limnologists, confirming the results of full-scale Speece Cone oxygenation. This data set shows oxygen levels over a 5-year period, measured at the bottom of a large reservoir. Before oxygenation, the warmer months had 0 DO. With oxygenation, elevated DO levels have been sustained throughout the year. Phosphorus, ammonia, iron, manganese, chlorophyll A, clarity, and cyanobacteria counts are all drastically reduced. In case after case, results are clear, and so is the water. Here are a few examples of ECO2 systems at work. In Georgia, the Army Corps of Engineers designed this massive project to inject up to 40,000 pounds of oxygen per day into the Savannah Harbor. Dissolved oxygen was required to sustain the ecosystem during and after dredging efforts to deepen and expand the harbor. The city of San Diego employs this technology at Lake Hodges to reduce taste and odor problems in the drinking water supply. The East Bay Municipal Utilities District installed one large Speece cone to stop internal nutrient release at the San Pablo Drinking Water Reservoir near Oakland, California. Natural water treatment using Speece Cone oxygenation is the proven solution for restoring impaired waterways.